everyone, welcome back. And today we are back here this month for another educational video. And this time I have been looking up some natural disasters and whatnot. And I thought, hey, why don't I do one on volcanoes? Because whenever I was younger, I did have a fascination with volcanoes. Still kind of do, as you can see. So I thought, why don't I learn some more about them? And then also look up some different volcanic eruptions and stuff like that, and it's kind of different stuff about them. So this month, we're going to do volcanoes. So, first off, what is a volcano? Well, I'm sure most of you kind of know. It's basically a hole in the ground, lava comes out. Yeah, that's basically a volcano. But it is a vent or fissure, or a hole in the ground, in the crust of a planetary mass object, so like Earth, and it allows hot lava, volcanic ash, and then also certain gases to escape from the magma chamber below the surface. Most often, they are found where tectonic plates are diverging or converging. We'll go over that later. And because most of the Earth's plate boundaries are underwater, most volcanoes are found underwater. Here is a little picture of a volcano here. So we have some of the easy things like the vent, which is at the top of the volcano, or the crater also. The conduit, which is like the tube that the lava comes out of. We also have some ash, which we could see is CO2, SO2, and H2O, and some other gases. The lava flows, and then also the magma chamber down there. We will go over more of the volcano, I want to say anatomy, but it's kind of the anatomy of them. So, the inside of a volcano. Let me move myself real quick so I'm in a better place. So, here is a volcano, okay? So, one will start very low, is the magma chamber down below. That's where all the magma is and whatnot. Then there's the bedrock, which is what the volcano, I guess, is built on. Then we have the conduit, like I said, the pipe that leads the lava up to the top. Then we have the base, which is where the volcano starts at. We have a sill. We have a dike, layers of ash emitted by the volcano, whatnot. 8, we have the flank. 9, layers of lava emitted by the volcano. Let's see where else. The throat is the very top where the lava is actually, I guess, where the conduit expands is the best way to put it, as you can see it up there. The parasitic cone, lava flow, vent, crater, ash clouds. Yeah, you can see where they're all at there. And I mean, there's certain ones that I'm not super knowledgeable on, but these are where they would be at on a volcano. So, there are a lot of things about volcanoes that we're going to be going over, but I thought first off we should probably start out with some terms that I'm going to be saying, because I will try to elaborate on them whenever we actually talk about them, but if I don't, this will be a term list of different things that I'm going to be talking about. So, magma chamber, we already looked at it. It is a large pool of liquid rock beneath the surface of the Earth. The volcanic crater is a circular depression in the ground caused by volcanic activity. It's typically around like a bowl-shaped feature, and it contains one or more vents. Volcanic gases. So these are a list of the kind of the gases that can come out of a volcano. So first of all, water vapor H2O, carbon dioxide CO2. Then we have sulfur dioxide SO2, hydrogen sulfide, which is H2S. We have also nitrogen, argon, helium, neon, methane, carbon monoxide, hydrogen. There's just a lot of stuff that comes out of volcanoes. We have the caldera, which is kind of like the volcanic crater. It's a large cauldron like hollow that formed shortly after an empty of the magma chamber and a volcanic eruption. So basically, after our magma chamber releases all of its lava, this is basically what's left, is the caldera. We have pyroclastic flows, which is a fast-moving current of hot gas and volcanic matter, which volcanic matter can be also the tephra. and that flows along the ground away from a volcano. Eruption column or the eruption plume can be basically used interchangeably. It is a cloud of superheated ash and tephra or volcanic matter suspended in gases, and it's emitted during a volcanic eruption. So basically, whenever a volcano actually erupts, all of the ash and stuff like that, and all the stuff that gets shot out, that is the eruption column or the eruption plume. Then we have the tephra there, which is fragmental material produced by a volcanic eruption. And it can be like fragment size and emplacement. There's lots of different sizes. Then we also have a vent, which is an opening that allows air, gas, or liquids to pass out of a confined space. A fault is a fracture between two blocks of rocks. Lava, the difference between lava and magma, we'll go over that too because it's a little bit nitpicky, but I mean, it's important. So lava is the molten rock that breaks through the Earth's surface. So on the ground, after it's already come out of a volcano, it's lava. Magma is molten rock that is underground. That's why it's a magma chamber, not a lava chamber. So whenever an eruption happens, you are seeing lava. Whenever it's in the ground, it is magma. Then there's also a type of volcano called a shield volcano, which is just a type of volcano named for its low profile. It resembles a shield laying on the ground. So it is not, it can be tall, but it's not steep. That's basically what I'm meaning by that. And then lithosphere, I know we talk about it a little bit there, but it is basically composed of the Earth's crust and also the lithospheric mantle, which is the toppermost portion of the upper mantle. So basically, just imagine it the crust, okay, the Earth's crust. So, before we actually learn about volcanoes, it's probably good to learn about plate tectonics. So, it is a scientific theory that the Earth's lithosphere is comprised of a number of large tectonic plates and have been moving slowly since 3 or 4 billion years ago. So, they've been moving a long time. The Earth's lithosphere, which is the rigid outer shell of the planet, includes the crust, upper mantle, and it is fractured into 7 or 8 major plates. The movement of plates typically ranges from 0 to 10 centimeters annually. So, that's where, like, you know how we were talking a while back about Gondwana and then Pangea and stuff like that? So these plate tectonics, the way they move, that's the reason why Pangea is not like still here. It broke apart, and that's basically why. As you can see, I have a picture here of the globe, and you can see, like they said, 7 or 8 major plates around here. So you can see the North American plate, South American plate, Pacific plate, Caribbean, Nazca, Africa, Eurasia, Somalian, Australian, Philippine, Pacific plate. Yeah. So there's all the plates there. And like they said, they move around 0 to 10 centimeters annually. So at these tectonic plate boundaries, there can be subduction, okay? So subduction is a geological process in which the ocean's lithosphere and some of the continental lithosphere is recycled into the Earth's mantle at a convergent boundary, so like the boundary of a tectonic plate. And this is where one tectonic plate will converge or go underneath a second plate, and the heavier plate will dive beneath the other and sink into the mantle. So basically, look at the picture here. One plate will go down, one will go over it. That's basically what it's saying. And the region where this process occurs is known as a subduction zone. And then you can look here at subduction. So there are different types of plate boundaries. There's 3 types to be exact. These are characterized by the way the plate moves relative to the other. So there's divergent boundaries, which can also be called constructive boundaries or extensional boundaries. There's convergent boundaries, which can also be known as destructive or active margins. Then there is transform boundaries, which is conservative boundaries or strike-slip boundaries. So let's look at all of these. So we have a divergent boundary. So this is where two plates will slide from each other. And it is formed by seafloor spreading and allows for the formation of new ocean basin and the Mid-Atlantic Ridge or the Eastern Pacific Rise. As the ocean plate splits apart, the ridge forms at the spreading center, and the ocean basin expands. Finally, the plate area increases, causing many small volcanoes or shallow earthquakes. So this is where basically some lava will come to the surface and instantly be turned into, I guess, new seafloor. And that's why they said that it is a new ocean basin is made. So some of the lithosphere and ocean basin is going underneath. This is where some more is coming to the surface and being made. Then we have convergent boundaries. So this is where two plates slide toward each other to form either a subduction zone, like we talked about before, or a continental collision. So I'm pretty sure continental collision, this is how like big mountains are made and stuff like that. So some will go to the surface, possibly make mountains. Others will go down and be recycled. Then we have a transform boundary, where plates are neither created nor destroyed. Instead, they'll just slide past each other. And the strong earthquakes can occur along a fault like this. So think of the San Andreas Fault in California as an example of a transform boundary. So let's get into the Ring of Fire, okay? So as you can see here, the Ring of Fire is basically along the western coast of South America and North America. And it also goes along near Japan, along the Philippines, and New Zealand and whatnot. So this is basically following plate tectonics. This is basically the area between plates. So it's also known as the Pacific Ring of Fire, the Rim of Fire, and the Girdle of Fire, or the Circum-Pacific Belt. A lot of names. It's a tectonic belt of volcanoes and earthquakes, and it is about 40,000 kilometers or 25,000 miles long, and up to 500 kilometers or 310 miles wide. And it surrounds most of the Pacific Ocean. And it contains between 750 to 915 active or dormant volcanoes. And this is around 2/3 of the world's total. About 90% of the world's earthquakes occur within this belt. So that's kind of the reason why, like California, the western coast of North America, and then also Japan, I know gets a lot of earthquakes and stuff like that. They are all along this Ring of Fire here, or nearby at least. And like it said there are tons and tons of different volcanoes that are near this area. So volcanoes are classified by really three different types. So volcanoes can be defined as either active, dormant, or extinct. So active volcanoes is a volcano that has erupted during the Holocene, which is about 11,700 years ago, and or is currently erupting or has the potential to erupt in the future. So basically, if it has erupted or is erupting within 1,700 years ago, it's an active volcano. There are dormant volcanoes, which are any volcano that is not showing any signs of unrest, such as earthquake swarms, ground swelling, or excessive gas emissions, but which show signs that it could yet become active again in the future. Many dormant volcanoes have not erupted for thousands of years, but have still shown signs. Then we have the extinct volcanoes, which are those that scientists consider unlikely to erupt again because the volcano no longer has a magma supply. So those are the three classifications. But there are many, many, many different types of volcanic eruptions. So let's go over some of these. So we have magmatic eruptions. So these are driven primarily by the gas release due to decompression. They have low viscosity magma with low dissolved gas, producing relatively gentle effusion eruptions. So these eruptions are not that bad. Then they also have high viscosity magma, which has a high content of dissolved gases and produce violent explosive eruptions. So there's really two different types of magmatic, either high or low viscosity. Low viscosity, not very bad eruption. High viscosity, could be pretty bad. Then we have the Hawaiian eruptions, which are named after the Hawaiian volcanoes. And these are typical of volcanoes that erupt mafic lava with a relatively low gas content. Almost entirely effusive or a steady flow and produce local lava fountains and highly fluid lava that flows but is relatively little fragmented material. The eruption column does not exceed 2 kilometers or 1.2 miles in height. And as we're going over these, after I get to the next slide, we will go over some examples of certain eruption types. Then we have the Strombolian eruptions, which are characterized by moderate viscosities and dissolved gas levels. They are frequent but short-lived eruptions that can produce eruptive columns hundreds of meters high. The primary product is scoria, and they are named after Stromboli, and we'll go over Stromboli. The ejection of cinders, lapilli, and volcanic bombs to altitudes tens to a few hundred meters high. So let's go over the Hawaiian Islands. The Hawaiian Islands consist of 137 volcanic islands, Hawaii, the big island, being the largest, and that's the one we're going to go over. The island of Hawaii is built from 5 separate shield volcanoes. We already talked about those, kind of lower to the ground, not very steep or anything like that, kind of looking like a shield. First of the volcanoes, we have Kohala, which is an extinct volcano of the Hawaii island. Then we have Mauna Kea, which is a dormant volcano, like we said, probably not going to erupt anytime soon, but also has the ability to, I guess. Then we have Hualalai, which is an active volcano. Then we have the biggest of them, Mauna Loa, which is an active volcano. Then we have Kilauea, which is an active volcano also. And those are the 5 volcanoes that are on the big island, the largest of them. Between January of 1983 and September 2002, lava flows have also added 543 acres to the island. And then you can see a picture there of all 5 of them. Mauna Loa is the Earth's largest active volcano by both mass and volume. It is a shield volcano with relatively gentle slopes and a volume consisting of 18,000 cubic miles. And the eruptions of this volcano are pretty much silica poor and very fluid and tend to be non-explosive. Most recent eruption for this volcano began in November 27th of 2022 and ended in December 13th of 2022, which was the first eruption since 1984. And then we have a picture there of Mauna Loa. Then, like I said, we are going to talk about Mount Stromboli, which is located on Stromboli, an island off the northern coast of Sicily, and one of the 4 active volcanoes in Italy. Mount Stromboli has been in almost continuous eruption for the past 2,000 to 5,000 years, and the last serious one occurred in 1921. And there you go. You can see Mount Stromboli, and then you can also see a map of kind of where it's at for Italy. Okay, more types of volcanic eruptions. So we have the Volcanian eruptions, which are named after volcano. It's characterized by yet higher viscosities and partial crystallization of magma. The eruptions take a form of short-lived explosions for several hours, which destroy a central dome and eject a large lava blocks and bombs. It is followed by an effusive phase that rebuilds the central dome, and the eruption columns do not exceed 20 kilometers or 12 miles in height. Then we have the Pelean eruptions, which are named after Mount Pele. It's characterized by the dome growth and collapse that produces various kinds of proclastic flows. Proclastic flows being a fast-moving current of hot gas or volcanic matter, like we talked about before. And the speeds of this can average about 100 kilometers per an hour, but it's capable of reaching 700 kilometers per an hour, so it can go very, very fast. So, we have Volcano, a small volcanic island belonging to Italy in the Tyrrhenian Sea, around 20 kilometers or 12 miles north of Sicily. The English word for volcano derives from the name of this island, which derives from the Roman belief that the tiny island was the chimney of Vulcan, the Roman god of fire. And in November 2021, 150 people were evacuated from the island's harbor area due to increased volcanic activity and gases. And that was the newest, I guess, not really eruption, but activity. And you can see there, we have Volcano there. And then we have a little picture of the sea around there, and you can see all the different. We have Stromboli there. You can also see we have Sicily, we have all of Italy, and then you see Volcano and a few different other islands. Then we have Mount Pele, meaning the bald mountain or peeled mountain in French. It is an active volcano at the northern end of Martinique. The most recent eruption for this was in 1932. And then in 1902, eruption destroyed the town of Saint Pierre, killing 29,000 to 30,000 people in the space of a few minutes, and is one of the worst volcanic disasters in the 20th century. So then you can see a picture of Mount Pele over there, and then also behind me you can see where it is on the globe. So some more types of volcanic eruptions. First, we have the Pleiadian eruptions, which are characterized by sustained huge eruption columns whose collapse produces catastrophic protoclastic flows. Oh, that's a word. And are named after Pliny the Younger, who chronicled the Pleiadian eruption of Mount Vesuvius in 79 AD. Then we also have the ultra-Plinian eruptions, which are the largest of all volcanic eruptions, are more intense and have higher eruption rates than Plinian ones, and form higher eruption columns and may form larger calderas. These produce rhyolitic lava, tempera, pumice, and thick protoclastic flows that cover vast areas, and many produce widespread ashfall deposits. So, we were talking about Mount Vesuvius, right? Here's Mount Vesuvius. So, first, Mount Vesuvius is, of course, in Italy. Right there, you can see on the map. And then we have a picture of Mount Vesuvius over to our far side. Then also we have a picture here of that an artist drew of the destruction of Pompeii. I'm pretty sure from Mount Vesuvius. So Mount Vesuvius is located in the Gulf of Naples in Campania, Italy, around 9 kilometers or 5.6 miles east of Naples. The eruption of Mount Vesuvius in 79 AD destroyed the Roman cities of Pompeii and a few other settlements I have there that are a little bit hard for me to pronounce, but they're there. And are regarded as one of the most dangerous volcanoes in the world because 3 million people live near enough to it to be affected by an eruption if it was to happen again. The eruption ejected a cloud of stones, ash, and volcanic gases to a height of 33 kilometers or 21 miles high. So it is a very dangerous volcano if it was to erupt again. And that art, the drawing here, whatever, is just, well, the painting is just beautiful. I love it. Then we have Mount Mazama, which is a complex volcano in the western U.S. state of Oregon. And it also has a crater lake at the very top, and it is 1,943 feet or 592 meters deep. And it is the deepest freshwater body in the U.S. The last eruption for this was 7,700 years ago, and the last active around 4,800 years ago. So it is very much still active. And I have a picture there of Crater Lake, and then also where it is over there in Oregon. So we still have a few more types of volcanic eruptions. Then we have phreatomagmatic eruptions, which are hydrovolcanic, and they are characterized by the intersection of rising magma with groundwater. And it's driven by the resulting rapid buildup of pressure caused by the superheated groundwater. So basically, just a lot of steam being built up because of the magma heating up the groundwater. Then we have the phreatic eruptions, which are characterized by the superheating of groundwater that comes in contact with hot rock or magma. And it's distinguished from the other type because the erupted material is all country rock and no magma is erupted. So, one, there's actually like magma that's erupted. Another one, it's all country rock. So, here we have the Volcanic Explosivity Index, or the VEI. So it is a scale used to measure the size of volcanic eruptions, and the ranges from 0, which are the Hawaiian types that basically don't explode at all, to 8 for supervolcanic eruptions. And about 40 eruptions of the VEI are 8 magnitude within the last 132 million years. So there have only been like 40 eruptions that have been considered like super bad, a level 8. And their estimated frequency is on the order of about every 50,000 years there is a 8 magnitude one. And you can see here we have like Mount St. Helens is on there, Tambora, and then also at the very end, which is not depicted, it says here, is the Yellowstone caldera, which 600,000 years ago. So, since we were talking about the like VEI or explosivity index, we should talk about the number 8s, the supervolcanoes. A supervolcano is a volcano that has had an eruption with a volcanic explosivity index VEI of 8. And it means the volume of deposits for such an eruption is greater than 1,000 cubic kilometers or 240 cubic miles. And then we have a picture here, and all of the ones that are red are ones that are considered supervolcanoes. The ones that are orange are considered 7s. And we have the Yellowstone over there in the United States. Over in South America, we can see a pretty good cluster of them. Then there is, of course, the ones over in Italy. There's some off the southern coast of Japan. One in New Zealand, right there on my shoulder. Yeah, so there are a few that are considered supervolcanoes. So, I'm going to talk about the Yellowstone caldera because the Yellowstone's supervolcano is one that very much is on my continent. So, it has a volcanic plateau spanning parts of Wyoming, Idaho, and Montana, so 3 different states, and comprises 4 overlapping calderas and multiple lava domes, resurgent domes, and crater lakes. So, even though it is considered like one volcano, there are multiple overlapping ones that combine to this Yellowstone volcano. And the most recent super eruption was about 0.63 million years ago, so it's been a while, and produced the Lava Creek Tuft. And we can see there a picture of what the magma and the Earth's crust, geysers, and stuff like that. Then we have a picture here of the Yellowstone National Park, which shows the caldera's edge. And that takes up a huge area. So yeah, it'd be very bad if any supervolcanoes go off, just because of how large they are. So we have decade volcanoes, which are 16 volcanoes identified as being worthy of particular study in the light of their history of large destructive eruptions, and are also proximate to populated areas. So I'm not going to go over all of these, because there's quite a few, and also some of them are kind of hard to say. But this is the list of the 16 volcanoes, and we can see Vesuvius is on there that we talked about. We have um, Mauna Loa, yeah, it's on there, and there's a few others. So like there's some in Russia, Mexico, Italy, the U.S., Indonesia, Congo, Japan, Guatemala, Greece, Philippines, Spain, New Guinea, Japan again, Italy again. So yeah, there's multiple of them. So, not everything is bad with volcanoes, not everything, because afterwards, after a volcanic eruption, there are some benefits. So, volcanic ash and weathered basalt produce some of the most fertile soil in the world, rich in nutrients such as iron, magnesium, potassium, calcium, and phosphorus. So, areas that have had volcanic flows and whatnot there are very good for growing plants and whatnot. Volcanic activity is responsible for the emplacing of valuable mineral resources such as metal ores. So they come out of the Earth's crust up to the surface and get deposited with the lava flows and whatnot, so we can get good amounts of metal ores. Then the high rates of heat flow from the Earth's interior can be tapped as geothermal power. So that's one good thing, geothermal. Then also I didn't have it listed, but I know there like the areas that do have volcanoes like really have a lot of tourist attractions and whatnot because people want to see the volcanoes erupt, which understandable as long as it's not dangerous. I wouldn't mind going to see a volcano. But there is this little thing called a volcanic winter. Okay, so it is caused by the volcanic eruption, and it's a reduction in a global temperature caused by the droplets of sulfuric acid obscuring the sun, raising the Earth's reflection of solar radiation. It reflects more sunlight after a large sulfur-rich explosive volcanic eruption. So all the ash and stuff like that and volcanic gases that get put up into the Earth's atmosphere, especially sulfuric acid and whatnot there, reflects all the solar radiation and cools down the Earth quite a bit. So that's why we call it a volcanic winter, because it's a cooling of the Earth caused by volcanoes. Yeah, and also caused like acid rain and what other stuff do we have on here? Just a lot of stuff. But Earth is not the only place that has volcanoes. No, sir. Io is one of the most volcanically active objects in our solar system because of the tidal interaction with Jupiter. Basically, tidal interaction is basically because Jupiter is so big. It I guess energy, like the gravity energy of it pulling on Io, heats it up. And Io is covered with volcanoes that erupt sulfur, sulfur dioxide, and silicate rocks. And its lava is the hottest known anywhere in the solar systems, with temperatures exceeding 1,800 Kelvin, which is 1,500 degrees Celsius. And they have a picture here of Io. And then, if you didn't think volcanoes could get any weirder, okay, there are cryovolcanoes, which instead of like hot magma or lava erupting, it's a type of volcano that erupts gases and also volatile liquids such as liquid water, ammonia, and hydrocarbons. The erupted material is collectively referred to cryolava because immediately after eruption, the cryolava quickly freezes. And although it is rare in our inner solar system, past the recent cryovolcanism is common on other planets in our outer solar system, especially on icy moons. So it's kind of rare where we're at, but out in the reaches of space, like outside our solar system, it's pretty common. Cryovolcanism is driven by escaping internal heat from within a celestial object and often supplied by excessive tidal heating, which here I probably should have waited to talk about tidal like movement because it's the orbital and rotational energy that a planet is giving off as heat. So yeah, not only is there hot lava, there's, well, I guess the cryo lava is still hot, but it freezes instantly. So, but that is all I have for volcanoes. We went over some weird things like volcanoes on other planets and cryovolcanoes. What else we go over? We get over volcanic winters and stuff like that. Benefits of volcanoes, some of the decade volcanoes. Super volcanoes like Yellowstone. Um, the different types of eruptions and what types of volcanoes like are they're named after, like Mount Vesuvius, which is one of the most well known I knew about. Um, then volcano, the word volcano coming from this island volcano, which has a volcano named Volcano. Pretty dang cool. I was interested to learn about that. Mount Stromboli, Mauna Loa. I've always wanted to go to Hawaii. I haven't yet, but maybe in the future I can go to Hawaii and maybe see a volcano. Um, yes, Hawaiian Islands, the classification between active, dormant, and extinct, the Ring of Fire, and then all of the boundaries and plate tectonics and subduction, all that stuff, and then just inside of a volcano. So we have gone over a lot of stuff today, a lot of stuff. This was probably one of the longest slideshows I've made so far. I don't know how long the video is going to be after editing and whatnot, but I hope you all enjoyed. If you were younger and, like me, was super interested in volcanoes, my brother was really interested in tornadoes. Me, on the other hand, I was more interested in volcanoes than like tornadoes. But they're very, very cool and very, very destructive. Just don't want to be around them whenever they actually go erupting. But it is a natural thing that the Earth does, and it's going to continue to happen as long as the Earth is around. So, I mean, we just got to kind of get used to it if we haven't already. But yeah, I hope you enjoyed learning about volcanoes with me, about all the different eruption types, different types of volcanoes, and going over all the different volcano types and what volcanoes are named after. Um, yeah, just a lot of stuff. I had a lot of fun doing this, a lot more fun than I thought I was going to about lava coming out of the earth. But it's cool, okay? Especially how volcanoes make islands like the Hawaiian Islands, because they make real estate, okay? Volcanoes make real estate there in the ocean. And without them, we wouldn't have really a lot of islands and whatnot. Oh, something I did not talk about that we talked about a little earlier on another one of my ocean videos. Basically about atolls, because atolls were volcanoes that have been eroded away. So I didn't add that in here because we kind of talked about that already. But an atoll, an island will eventually erode down into an atoll, which was an old volcano that's eroded away. Quick fact. But yeah. Thank you all for watching. I hope you enjoyed. I will see you guys next month with whatever educational video I have in store. Haven't quite decided. I'll have to think. But I hope you all enjoyed as much as I did. So, thank you all for watching. I hope you enjoyed, and I will see you guys next time. So, bye-bye.